Welcome back to MetaMath. In this video, I'm going to be covering the 2020 AIME I problem number 6, which reads as following. A flat board has a circular hole with radius 1 and a circular hole with radius 2, such that the distance between the centers of the two holes is 7. Two spheres with equal radii sit in the two holes such that the spheres are tangent to each other. The square of the radius of the spheres is m over n, where m and n are relatively prime positive integers. Find m plus n. So after reading this, it's clear that this is going to be a geometry problem. So the first thing we want to do with any geometry problem is draw a diagram. And so what I've drawn right here is a cross-section of the board. So the spheres are actually circles in this cross-section view, and the circular holes are lines. And the blue line is the circular hole with the radius 1, and the red line is the circular hole with the radius 2. And this is especially useful for this problem because we can add all the information and we can work very well with one-dimensional and two-dimensional figures in this diagram here. Now, if we go here, this is a top-down view, and this isn't as useful for the problem, but it does help us obtain the cross-section view. The cross-section view is if we're looking right at it and we chop off the parallel portion of it. The top-down view is going to be if we're looking right at it from above. And we can't place the sphere in it without overcomplicating it, so we can't really use it for the problem. But if you see here, the circle is condensed into the purple line on both fronts. So we have the circular holes condensed into lines, and the spheres condensed into circles. So now that we have established how to get the diagram, let's start to fill it in with the information in the problem. The distance between the centers of the two holes is 7. So this distance right here is going to be 7. The radius of the spheres is equal, so we can label each one as r and r. And we know that they're tangent to each other, which is why we connected them in the first place. Now we can start to connect some other points. So we connect the sphere to the hole, and we draw this line that's on the sphere, and we get a right triangle here. We know that this is perpendicular, and likewise we draw the same thing on the other sphere. Connect this line, we get a right triangle with a hypotenuse of r. We know the one leg, so we can solve for the other leg. So square root of r squared minus 1 and square root of r squared minus 2 squared, which is 4 by Pythagorean theorem. Now that we have some side lengths here, we can set up a third triangle by connecting the elevation of the two spheres, because the second sphere is lower than the first sphere. So if we connect this, we have a leg of 7, a hypotenuse of 2r, and another leg, which is a difference between r squared minus 1 and r squared minus 4. So with that, we can set up a right triangle and we can solve for r. So the hypotenuse is 2r, so 2r squared equals 7 squared, plus we have the difference between r squared minus 1 minus r squared minus 4. Take all that squared. There we go. So now we just expand everything. 4r squared equal to 49, plus when we expand this, we'll get an r squared minus 1 term, we'll get an r squared minus 4 term, and we'll get the product of the two. So we'll get a minus 2 square root r squared minus 1, r squared minus 4. And we'll leave it in that form for now. We can expand that later. So we want to start to move everything to one side. We'll move everything except the square root side to the right-hand side. So we'll write it as 2 r squared minus 1 times r squared minus 4 on the left-hand side. But on this side, we're going to have 44, so 49 minus 5, minus 2r squared, because we moved the 4r squared to the right side. And now that we have everything shifted onto one side, we can divide by 2, and then square the left-hand side and get rid of the square root. So if we divide by 2, this is going to become 22, and this is just going to become minus r squared. So we square this, and we get r squared minus 1 times r squared minus 4 is equal to 22 minus r squared squared. So we can expand this, and expanding the left side gives us r to the 4th minus 5r squared plus 4 is equal to r to the 4th. We have minus 44 r squared, and 22 squared is going to be 484. We can cancel out r to the 4th here on both sides. We can add the 44 r squared to this side. So we have 39 r squared is equal to 480. Now that we have the value for r squared, we can divide by 39 and finish off our value for r squared, which is going to be 480 divided by 39. 480 and 39 have a common divisor of 3, so that's going to be 160 divided by 13. 160 and 13 are relatively prime, so this is going to be our value for r squared. And if we go back to the problem, which is asking for the value of the square of the radius of the spheres, and we know what that is, that's r squared, which we solve for. They want the sum of m plus n. Well, we simply take 160 plus 13, and we get our answer, 173, and we're done.